Okay, so we're carrying on this decomposition of forces. So let's consider example 10.2. Pulling a friend on a swing. It was a very nice problem. You're pulling a friend on a swing and you are holding your friend in place, in position, okay? So there's no acceleration. Your friend isn't moving up or to the side. You're just holding your friend in this position. Now, as you can see, there's an angle there, okay, that the cable that holds your friend up, okay, that cable makes with the vertical. And then you're applying a force, and then there's also gravity. So we'll look at the free body diagram in a minute. It says here, as you increase the angle theta, okay, how are you going to increase that? Well, if you pull, and then you pull your friend towards you, then that angle will increase. If you pull a little bit more, the angle will increase. If you let go, that angle will decrease. Okay? So as you increase the angle theta, does the magnitude of that force, does it increase or decrease as you increase that angle? Okay. So a lot of people in class automatically says that as this angle is increased, this force to keep this your friend in place increases. Okay, and that's the right answer. But let's look at how you actually can prove this, which is kind of what we're after here. So the first step always is, let's draw a free body diagram. There is the X, the center of mass of the friend, and you've got gravity acting down. You've got this force of the rope acting to the left, gravity acting down, the force of the rope acting to the left, and then you've got this cable force over here pointing towards this direction, as you can see. Okay, so in actual fact, you've only got these three forces. So this is the force of the rope on the person, this is the force of earth on the person, and this is the force of the swing on the person, or suspension point. I'm not sure exactly what it is, but it's the force of that cable. Very good. Okay, and then of course, this is that same angle. Okay, if you draw alternate angles, then that angle there is the same as that. So if you make that angle larger, you're going to make that angle larger. Okay. Now the question is this: if you increase this angle, does this force required to maintain your friend in this position, does that increase or decrease? Well, the way that we can look at it in this solution is that in the vertical direction, our acceleration is zero. So there's no acceleration in the vertical direction, which means that the gravitational force that's acting down must be balanced by a vertical component, so that there's no acceleration in the vertical direction. So where are we getting that vertical component? We're getting it from this cable, the vertical component of this cable. So that is FSP. This component of this force must match, must be equal and opposite to the gravitational force. Okay, I think that's pretty easy to understand. And then of course, the X component of that cable force, that swing force, must also be equal and opposite to this applied force, because there's no acceleration in the horizontal direction either. Okay? So I think we're happy with this. But now what happens if we increase this angle? If we increase the angle, these two forces must remain the same. Okay? Why? Because the gravitational force doesn't change. The downward gravitational force doesn't change. So the force that is required to keep this person up in the vertical direction must still be the same as before. Because the gravitational force doesn't change in both of those situations, the vertical component of this force must be the same in both of those cases. All right? Otherwise, there's acceleration. Now, the thing is, as you increase this angle, the only way that that this vertical component can remain the same in both cases is if this force in this cable increases. Can you see that the length of this force over here is larger than the length of the force over here? Okay? So as you increase this angle, in order to maintain the same vertical component, the force itself must get larger. And if the force gets larger, then the horizontal component must also get larger than this component over here. And so, as you can see, the rope force to hold your friend at a larger angle must indeed be larger than the one over here. Okay? So that's all I'm doing for this one. I'm just doing part A. Try to do part B and C. The solution is down there.